Hello, bonjour, bienvenue, welcome. In this module, I'll be showing you how to create some charts. So Excel is a powerful tool for manipulating and analyzing data, but it's also important to be able to visually represent those data in order to communicate effectively various trends and patterns and correlations. So in this module, I'll review how to prepare some graphs or charts as they're called in Excel. And these charts illustrate data from different queries and analyses. More specifically, we'll consider how to prepare a scatter plot, an XY, otherwise called an XY plot, a pie chart, and a stacked column plot. We'll also briefly look at how these plots can be formatted. So first, let's begin with a simple XY plot. This is probably the most commonly used plot in the sciences, where the Y value represents a dependent variable that varies according to a numerical relation with the independent variable, which is shown on the x-axis. In other words, these data derive from an experiment where you vary x and measure y. So to illustrate this example, I'll use this Lineweaver-Burke data set that I prepared in a different module. The first thing to do to prepare a chart is to select the data to be plotted. Ideally, the x-axis data will be on the left, and the y-axis data will be on a column to the right of the x-axis data. Excel will assume that the data in the leftmost column contains the x-axis data. So if the two columns are side by side, as they are here, the first column can be selected by clicking and dragging, and the second column at the same time. If they're separated, you can select the x-axis by clicking and dragging, and then the y-axis by holding down Control as you click and drag. So now that we've selected the data, including the headers, we now have to tell Excel what kind of plot to make. So here we go to the Insert menu, and the chart that we want to insert is a scatter plot. It's very important to select a numerical XY or scatter plot. I've seen many students make the mistake of creating a category plot where the x-axis numbers are merely used as labels and not as their numerical values. So after the correct scatter plot is created, we can quickly format this by selecting one of the presets. For example, a quick layout that has grid lines and axis titles. Now we can format this further. For example, we don't need a legend. And we can enter the names for the axis titles either directly by replacing axis title with the name of the axis, in this case 1 over the concentration of S in units of 1 over millimolar. As shown here. Or we can select the the y-axis title box and go to the formula line to tell Excel to refer to a cell in the spreadsheet. In this case, F3, the name of the y-axis data. Now, if the contents of cell F3 change, the title of the y-axis will be updated automatically. From here, we can format this graph further, and one of the easiest ways to do so is to call up the Format pane by right-clicking the chart area and selecting Format Chart Area. Here, we can change the color and size of the data points, for example. If I select the data series and then the marker options, I can change the size of my circles. I can change the color of the fill. I can change the color of the border, etc. Back on the home menu bar, we can also change the font to be bold, to be larger, to be black, and so on. We can also add a trend line through these data by selecting the data series, right-clicking, and adding a trend line. In the Format pane, we can accept the option for this trend line to be linear, and we can also ask Excel to extend the trend line forward or backwards. In the case of a Lineweaver-Burke plot, which is what we're preparing here, we like to visualize the x-axis intercept. So we would need to extend the trend line backwards by, let's say, an even 0.2 x-axis units. Now you can see that the line has been extended back to minus 0.2, but we actually don't need to see the negative x, negative y quadrant on a Lineweaver-Burke plot. It makes no sense either physically or visually to represent the negative y-axis at all. So if we select the y-axis, we can return to the Format pane, and in the numerical options of the axis options, we can set the minimum value of the y-axis to 0. Now we have a trend line that passes through the data points, and we can see where it intercepts the x-axis. We can also select the trend line again and ask Excel to display the equation for this trend line directly on the chart, along with the correlation or the r-squared value. And finally, we can see that the slope, the y-intercept, and the x-intercept shown on this chart correspond exactly to those that we calculated explicitly in a previous module. Next, let's look at how to make a pie chart. So for this example, I've mined some fictitious student data in order to count how many students are enrolled in the English program and how many students are enrolled in a French program. So I used some queries using the COUNTIF formula to count the number of students enrolled in the English program and to count the number of students enrolled in a French program. And I'll explain how to use COUNTIF formulas in another tutorial. So while the absolute number of students in each language stream might not be particularly meaningful to all viewers, I think everyone can appreciate how a pie chart visually represents the relative proportion of each group. So to create a pie chart, first we select the data, including the headers, and then we insert a chart of the pie chart variety. We can also format the way this chart is presented, for example, by adding a chart title, by changing the font appearance. And another useful formatting is to right-click on the pie chart itself and add data labels. This adds the number represented in each section of the pie. In the final example for this tutorial, let's consider how to make a stacked column chart. So the data for this chart were prepared by mining that same set of fictitious student enrollment data using formulas to count the number of students with respect to two criteria: their sex and their citizenship status. So I used COUNTIFs formulas to do this counting, to count students with respect to their sex and with respect to their citizenship status, and I'll explain how to do that in a different tutorial. So in this case, to make a stacked column chart, we select the data, including the headers, and then we insert a chart of the column variety, specifically a stacked column. Now, this is a way of presenting data in columns that correspond to one category while dividing those columns according to another category. So in this case, the primary category is citizenship, and the secondary category shown is the sex of the student. And if I want to present the data in a different way, I can simply switch on switch row column in order to make the sex of the student the primary category and the citizenship the secondary category. So you can switch the same data back and forth. Now we can quickly reformat the chart in the usual ways. We can enter a title, we can change the color, we can add data labels to a series to show the absolute number of students in each section, and we can change the font of the entire chart on the home menu, as we've done before.